Hi. Well, hello everyone. Thanks for coming. I'm William, and I'm here to talk about the challenges that we had while extracting Ethereum Node Data from the context of my own product, which is called Otterscan. First, let me do a quick introduction about myself. You can find me under this ID on every social network, and I created the Otterscan over 2 years ago. Just to give you some introduction about my product, Otterscan. Who here in the audience know what Otterscan is, please? Okay, good. Well, just to give entire context for everyone here, Otterscan is basically a block explorer that you can self-host it. It's open source, and well, the secret sauce is that anyone can run in consumer hardware due to its own low hardware requirements. Think of it like Etherscan, but you can actually run at your home. But before we talk about the challenges, let's take a look at how other similar software works, either proprietary or closed or open source, and which problems we wanted to address specifically. Here's an architecture diagram for any generic application like a block explorer. You usually first have an archive node. It could be any archive node from any Ethereum client. You usually have some middleware software that scrapes this data from your node using the standard APIs like the debug and trace APIs, and you usually take this data and store in a more consumption-friendly format inside a SQL database. And you have your application reading this data from the SQL database instead of the Ethereum node. There are some issues with this approach. First, we may have some data duplication between the node and the database, which is not very good when you talk about the constrained environments. Also, you push some burden to the users because they now have to install, configure, and maintain additional software. You require some DevOps-ish level of knowledge from your users. I just want to state there is nothing wrong with that approach. It works perfectly, but in our context, we wanted to really have some very light dApp that could be run on consumer hardware, so we thought we could do better. In order to understand our decisions, first I'd like to state our vision for what we think an Ethereum node should do and how it should do. First, we think that Ethereum clients should provide higher level primitives, higher than headers, blocks, and transactions, which is the basic building blocks that any Ethereum client provides, but that's very low level. Users actually, what they care is about the blockchain actions and their effects. For example, we think that Ethereum clients must answer for example, this very basic question, giving your addresses, what are my transactions, and what are my token balances. And also another example of question we think that clients should answer is, let's say you broadcast your transaction to the network, this transaction is included inside a block, and which effects did it have on my account? Not just a transaction executor or not. Did they receive more tokens? Did they send tokens? Which tokens? In which order? And this is something that we don't have so easily just by querying Ethereum nodes by using the standard APIs. And we work towards, our solution works towards solving those issues. So now let's get back to our original diagram. What we proposed was to simply get rid of everything in the middle, cut the middleman. In our vision, the application should talk directly to an Ethereum node and more specifically, in our case, an Aragon node, so and get everything he needs. Why we did do that? Well, just a quick pause. Everything knows what Aragon is. Okay, I guess so. Well, Aragon is an Ethereum client like any other, but it's long answer short, Aragon is specialized in archive nodes. And 2 years ago, when I started my project, Aragon was the only client able to provide an archive node that anyone could run in consumer hardware. It has very low footprint. It syncs in between over 1 week. All mainnet history fits under 2.3 terabytes. So 2.3 terabytes is too high for, if you think just about the number, but it's something doable. You can buy some large SSD on Amazon and have a mainnet history at your home. You don't need to rely on cloud. So going back to our initial architecture, the reason we wanted to, then our motivation was to cut this middleman, but why? Because in this traditional architecture, you have this middleware scraping data from your archive node, but it's not very efficient, it's slow, it relies on slow, hungry network interfaces. You usually use debug and trace APIs, which is something that is, they are heavy operations, and you have this binary data being serialized and deserialized from both sides. Everything adds some costs and make all the process very slow. What we did was, okay, let's cut the middleman and push everything inside the node, because I realized that at least for our purposes, we could do it, and it could provide everything that we needed. So why we chose Aragon? Well, besides being the only archive node being able to provide the data we needed, it's also because Aragon is very easy to customize. It's very easy to add new methods. It's very easy to understand the internal database schema. It's easy to produce new derived data on top of this raw data. And we also save those derived data inside the Aragon database itself on separate tables. So everything goes self-contained. It's very good for us. It's a very simple architecture. And as a result of this approach, we end up with a new set of JSON RPC methods under our own namespace, which is called OTS, which you need to enable by yourself. But with this approach, we are able to provide everything from the node itself without having to use any middleware between the application and the nodes. But of course, we had some trade-offs that we are aware of. First one, is most obvious, is the client lock-in, more specifically with Aragon. But I don't think this is necessarily an issue for us. Why? Well, first of all, I think that anyone who came in contact with the standard JSON APIs before knows that the current state of the APIs is that they are quite stagnant. There's no one actively working towards evolving them. There are a few initiatives, isolated initiatives, but there's no ongoing efforts in order to evolve them over our clients. So it's hard to try to make something that's very client independent, because the common denominator is not very does not provide much. And we think that if your APIs are successful, some other clients may be interested in implementing them by themselves, and that would be a good incentive to increase competition and increase, for instance, hence increase client diversity on the execution layer. In fact, this is exactly what is happening recently. Otterscan, we maintain the reference implementation of the Otterscan APIs inside Aragon. By the way, Aragon sponsor us to do that work. But there's been some other community implementations in other clients going on. As an example, there's a community effort from some users trying to implement Otterscan APIs inside Ref. This is the public GitHub issue. You can follow the development of those APIs there. This is another very interesting example, which is another user from the community that he implemented the Otterscan APIs inside Envil. You know Envil. You can just point to Otterscan to an Envil recent version of Envil node, and you can have the same block explorer you have for mainnet, testnet, or any other network that Aragon supports, but for your DevNet. So you have a very good, very smooth user experience. And by the way, this is how it looks. It's the same Otterscan, but for DevNet, you can see block number 3. It's a test token. And again, talking about challenges, finding a good API granularity is hard. Our goal is to find a better abstraction than just header and blocks, but try to not go too far from that. Why? Well, we think that we realize that ERC-based abstractions is good, let's say having methods to get a paginated list of all your token transactions is something very desirable, but having a very specific DeFi protocol, for example, a specific method, is not worth it because you don't know the future of this protocol. You will have to maintain it forever. We think it's not good to try to invest in this area. What we think is that eventually other people can build more higher specific abstraction on top of our APIs, and that's what our current approach. And what is the current status of our APIs? We recently released some internal indexers that expose some ERC-based contract, we call contract classifiers, because it just traverses the chains and try to identify the contracts using many techniques. The overhead is very low compared to the entire size of an archive node, so we think it'll be okay. It's an opt-in feature, so if you are just a regular Aragon user, you just want to have your validator, you don't need to have your Otterscan indexers taking more disk space, whatever is the size of it. For example, what you can do with those APIs, you can easily get token lists. You can have variations of these getter methods for many ERC standards, and we will have many more in the future. And you also have APIs for getting token transfer lists. Our goal in the future, of course, it's an ongoing work. We are going to optimize it more. We want to implement more indexers. At the same time, trying to find the optimal balance between having more specific and more generic features inside the node, because we also don't want to make Aragon some bloated nodes. But also allow users to eventually, that want to customize and install, let's say you create an indexer for your specific protocol, maybe you could do that on your own and deploy it inside your Aragon instance. And that's it. Thank you very much. Questions?
Hello, my name is Dennison from Tally. Forgive me if I missed the first part of the presentation, but is it possible to use Aragon and Otterscan for non-Ethereum mainnet EVM chains? Is it compatible across the ecosystem?
Yes, it should work with any Aragon node that any chain that Aragon supports. That currently it is, of course, mainnet, Polygon, Altasnets, Gnosis. There is a fork of Aragon called OP Aragon, which is maintained by another company called Testing Product. That they let you use Otterscan for any OP chain, as far as I know. I know that at least Optimism and Base networks are they work. I'm almost sure, but don't take my word for it, that it should work for any Optimism OP stack chain. Yes, yeah, I think most, let's say, famous chains are supported because the Aragon supports it, or someone who supports Aragon derivatives, they made it work.
Excellent. Thank you very much.
Thank you.
Give a round of applause. Oh, we got one question.
Question?
Okay. I just want, one question about, so one thing that you can get from Etherscan is there's a sort of uploaded data, whether it's like verified contracts or sort of tags of certain like addresses or those kind of things. Do you think about how that sort of off-chain data could be incorporated or made available on Otterscan?
Sorry, could you repeat? I couldn't hear.
Yeah, so basically about some of the off-chain data that, say, within Etherscan, you've got the uploaded verified contracts and you've got tags of accounts and that kind of metadata, which isn't derived from the chain, but is community provided or uploaded. Do you think about, have you thought about introducing that kind of information to Otterscan, so you could say, oh, this is the official Uniswap deployment, this is this like contract verification, those kind of things?
I'm not sure if I understand the question because there's a lot of echo in the room. But you were asking about labels and tags.
Yeah, and those kind of things.
We plan to have that, and of course, I think you mentioned Etherscan in the beginning, right?
Yeah.
I consider that a problem because you have all this data, which is it's effectively closed source. Etherscan owns this data. Although they allow you to use it for free, but as we saw some weeks ago with their instance for Avalanche, that's going to disappear, and also all this data is going to disappear too. I think it's important to have some kind of public version of this database, which we want to have this feature in Otterscan in the future, and we probably will work on something that will be an open public database. So even other open source implementations of competitors, block exports, we can cooperate in order to have this data open and free for everyone, truly open source.
Awesome.
Thank you.